In this example, we are asked to solve the inequality x plus 2 over x minus 4 is greater or equal to. This is an example of a rational inequality because the expression on the left-hand side of that inequality is a rational expression. You have to remember that if you are dealing with rational inequalities, you cannot divide or multiply both sides by something that contains the variable. In this case, it is tempting to multiply by the common denominator x minus 4. However, you cannot do that because you have to remember that if you are multiplying an inequality by a negative number, you have to reverse the inequality sign. And in this case, if you multiply both sides by x minus 4, you really don't know whether that x minus 4 is greater than 0 or less than 0. So you really don't know whether to keep that inequality sign or change it. Therefore, to solve such inequality, we'll have to follow the steps that are indicated on the left-hand side. As always, the first step in solving an inequality is to write it in the standard form and therefore bring all the terms to the left, get 0 on the right-hand side. So we'll have x plus 2 over x minus 4 minus 2 is greater or equal 0. The next step that will simplify the process is to combine the terms on the left and write it as a single fraction. So that means that we'll have to introduce common denominator, which in this case is going to be x minus 4, and therefore 2 will have to be multiplied by x minus 4 over x minus 4. That is our inequality, and if we simplify this, we'll end up with negative x plus 10 over x minus 4 is greater or equal to 0. Only now we can start the process of solving that inequality. So the next step, step 3, is to solve the two equations. Numerator equals 0, which will be x plus 10 equals 0. And the denominator equals 0, x minus 4 equals 0. The first equation gives me x equals 10. The second gives me x equals 4. Notice that the 0 of the denominator has to be excluded from our consideration because it makes the denominator 0 and therefore it is not in the domain of that expression. In step 4 and the following, we are going to make the sign chart for the expression on the left-hand side of our inequality and therefore sign chart for negative x plus 10 over x minus 4. That sign chart starts with the drawing number line and plotting the points obtained in the step 3. So these are 4 and 10 in that order. The number 4 has to be excluded from our consideration because it makes the denominator 0. So 4 cannot be ever included in the solution of the inequality. And in step 5, we'll determine the sign of that expression by making the table and using the test point in each of the intervals obtained by plotting points 4 and 10 and computing the value of expression x minus negative x plus 10 over x minus 4. That will determine sign of that expression in each interval. So in the first interval, we can choose, say, 0. If you choose 0, the value is going to be 10 over negative 4, which is negative, and therefore the whole expression has a negative sign or is negative in the interval from minus infinity to 4. In the interval from 4 to 10, we can choose, say, 5. Then we'll get as a value 5 over 1, which is positive, and therefore the expression is positive in this interval. And in the last interval, we can say choose 11, and the value is going to be negative 1 over 7, which is negative, and that means that my expression is negative in the whole interval. Once we have that number line. Once we have the sign chart, we are ready to write the solution. So our inequality reduced to negative x plus 10 over x minus 4 is greater or equal 0. So what I want to know is when this expression is positive or 0. So if I look at the number line, I'm looking for the plus sign, and the plus sign is only between between 4 and 10. So we can say that that expression is positive if x is in the interval from 4 to 10. 4 is not going to be included because it's excluded from the domain. 10, however, is going to be included because at x equal 10, the whole fraction is 0, and we allow 0 in our inequality.